Hello, everyone. My name is Priti Desai, and I work for IBM. I'm here today to talk to you about Tekton, an open source framework for creating CI/CD systems. And I have Jerop with me.
Hello everyone, my name is Jerop Kipruto and I'm a software engineer at Google working on cloud CICD, specifically Tekton. And I'm also delighted to be here to talk to you about Tekton.
So, Jerop, let's get started with our checklist. But before we start, what is so magical about this number or, 5 steps here? Why not 3 steps checklist or 7 step checklist?
So pretty, 5 steps is key here and we'll find out what they are. But first, let's learn what Tekton is. Tekton is part of the Continuous Delivery Foundation. It is a Kubernetes native open source framework for creating continuous integration and continuous delivery systems. It lets you build, test, and deploy across multiple cloud providers. It provides Kubernetes style resources for declaring CI/CD pipelines. Now, let's learn why Tekton. Standardization. Tekton standardizes CI/CD tooling and processes across many different vendors, languages, and deployment environments. It works well with Jenkins, Jenkins X, Scaffold, Knative, and many other popular CI/CD tools. Two, built-in best practices. Tekton lets us create CI/CD systems quickly, giving us scalable, serverless, cloud-native execution out of the box. Tekton is optimized for simplicity and reusability. Lastly, maximum flexibility. Tekton abstracts away the underlying implementation detail so that we can choose the build, test, and deploy workflow based on the team's requirements. So what are we all waiting for? Let's all migrate to Tekton. Or instead, how about we combine the power of Tekton pipelines with the other CI/CD tools to better serve our team's requirements? Let's begin by briefly looking at the 5 core building blocks of Tekton pipelines. 1, step. 2, task. 3, pipeline. 4, trigger. And lastly, catalog. We'll go through each one of them. 1, step is equivalent to a container image in which it executes a tool on the specified input parameters and produces an output. The second is a task, which executes a pod on your Kubernetes cluster. A task is a sequence of steps sharing an internal Tekton workspace, which is an implicit volume. The third is a pipeline, which is a collection of tasks running a set of pods. A pipeline is a graph which provides the flexibility to organize the workflow based on the requirements. A pipeline combines tasks to parameters, results, and workspaces, and also provides a task and step level isolation if needed. So I can manually run my Tekton pipeline, but how do I automatically run my pipeline? Such as when I push code or when I create a pull request. We have triggers for that, which has event listeners that trigger pipeline runs based on the events. The trigger binding extracts relevant information from the event payload. Then the trigger template provides a blueprint for creating the pipeline run. So instead of everyone creating their own tasks and pipelines, is there any way to share usable resources across the organization or even with the community? We have Tekton catalog, which can be shared across organizations and with the Tekton-wide community. It contains resources for foundational and advanced CICD use cases. Next, Priti will briefly look at the CICD ecosystem.
Thank you, Jerop. So we just looked at the core 5 building blocks, and Here, we are kind of looking at the CI/CD ecosystem. Not all the tools and technologies available right there, out there, but let's look at a couple of them and see how we can design using one technology or basically use multiple of these technologies. So the way we define pipeline in Tekton is basically equivalent to a workflow in Argo workflow and GitHub Actions, and similarly pipeline in Jenkins. The way we define task, uh, so this might not be a fair comparison or apples to apples comparison, but the way we define task is a pod in Tekton. There are a lot of different template types available in Argo workflow, and many of these template types also has like containers, scripts, etc. So, and GitHub Actions has jobs which is very similar to task, and Jenkins has stages. So the, all of these tools, they are meant for CI/CD systems, and they have their own principles, design guidelines, and most of these CI/CD use cases, they need the functionality where something there has to be basically getting executed something before the pipeline ends or exits. So in Tekton we have finally, which is guaranteed to be executed before the pipeline exits. In Argo workflow, there is something exit handler. In GitHub Actions, there is something called post actions, similarly in Jenkins. And we're going to look at Argo CD and GitHub Actions later on, and we'll have a demo for that. So let's first look at a very common CI/CD use case. So so this is a very common build, test, deploy, rollback pipeline. And here what's happening is developer is committing some changes or writing the application. What we are trying to do is cloning the application repo into the shared workspace. Then the linting, building, and testing, integration testing, everything is being done on workspace where the code was cloned. After all of these tasks finishes, we are building and publishing an image to a container registry, and we are using the same image to deploy on multiple clusters. For example, here we are deploying the same image on dev and stage cluster. Now, here the important distinction between the normal task and the task that we have defined before, and the deploy task is a iterative kind of functionality where the same task specifications are used to run same task run for develop dev cluster and the staging cluster. So basically, there is something called custom task that was recently introduced in Tekton, which is being used here. And what's happening in the end is, let's say, if the deployment on any one of the clusters fail, then we have uh, an option to roll back so that both the clusters basically are in the same state. So what next we are going to look at is the kind of it's the demo of how we have simplified this use case a little, but we have integrated Tekton and Argo CD to kind of show what is how the whole pipeline can be implemented. So we call it something like Robocat swims with octopus. Um, so for that particular use case, when a developer is committing a change and the image is being built and then the image is being deployed and basically is making made available, uh, here we need two Argo CD applications, one for the Tekton resources and one for the deployment. Um, and so but even before that, we need the secrets. So we need so from the pipeline, the task run, which is part of the pipeline, we need access to the Argo CD application so that we can basically sync the deployment. So for that, we need the secrets. And similarly, to push the images into container registry, the build and publish task needs access to the container registry. And that's why we need a service account for that. And like I said, we need two Argo CD applications. And the last one is webhook on the GitHub application repo where the developers are committing their changes so that basically the webhook payloads can be received by the triggers in the Tekton resources. So, and let's look at how the entire workflow looks like. So the very first step is developer is committing a change in the application GitHub repo, and that change is being picked up, and webhook is sending a payload to trigger Tekton triggers, and then Tekton triggers is triggering a pipeline run, which is basically cloning the application repo, building an image, and then publishing that image into container registry. Then the next task, sync and wait, is basically triggering the sync and wait task from the Tekton catalog, which is making sure that the deployment is in sync with whatever the latest image was built. So that's where the image is being deployed on the cluster and is available. So whatever changes the developers did are now available on the cluster. So let's look at this in action. We have a demo for this, and let's see. So if I can play this. So here I have a CDCon 2021 repo where I have where I have the Tekton resources and the deployment files. So here you'll see the pipeline. It's in a one directory, and then there's a deployment directory. So first of all, we are deploying the secrets, and this is how the secret files look like, of course, without secrets. So we are deploying, we have created a CDCon namespace, and that's where everything is happening. So deploying Argo CD secrets, followed by the service account for publishing the image. Now, next is I'm creating I'm creating here the CDCon, something called CDCon app build, to basically sync the Tekton pipeline resources here, the very first Argo CD application that we looked at. So you'll see that, yes, there is an application got created here, and it's referring to /pipeline and has all these resources. Now, next, we are syncing these resources so that those resources are available on the cluster. So let's look at the dashboard. So all these resources are getting created on the Tekton. Now we are creating one more Argo CD application called CDCon app deploy, and we'll see one more application here. And this is basically the deployment file. So now we have to, of course, port forward the event listener which we just created. Now we see there's a pipeline and all the resources exist here: trigger binding, trigger template, and also event listener. And there's no pipeline run yet. So let's see. Next, we would like to, first of all, let's go and add a webhook so that, yes, add a webhook so that we can, so I'm using a service to basically expose my, so that the GitHub can send a payload to my cluster. I'm using Docker Desktop here. I want application JSON, and then let's not worry about secret right now. Yes, so this is my webhook. Now I'm making a change in my application. This is a very simple Hello World application. I'm changing the application, and then let's commit the changes. So updating the version to 101, for example, git push. Now what I'm expecting is the, yes, there is a webhook, and it should trigger the event listener, and then basically event listener will trigger the run. So I have the build app image. I have fast forwarded this, but basically the image was built, and now the deployment, the Argo CD sync must be triggered, and which will basically sync the deployment. So here, yes, it says that a few seconds ago we synced, and we have the application running. Now, I'm changing the application to make it change the version to 01. And yes, we made those changes. Now let's commit and push those changes. Updating version to 201. So git push to master again. So this was the before we updated. Now let's see whether, yes, there is one more webhook, and which was created. Let's see. Yes, there is a pipeline run getting triggered, and fast forwarding a run. It built an image, and now it must uh, create a sync a deployment, and then wait basically for that deployment to be synced. So yes, is. It was successful, and then we have the other application. Yes, so it was a few seconds ago deploying, yes. So now we should see the version 101 to 201. Yes, so our changes are showing up now, and basically the whatever changes the developers are doing are showing up in the cluster.
Thank you, Priti. So after Robocat meets with Octopus, it goes on to play with Octocat. Here we look at a simple use case to plug and play with GitHub Actions and Tekton, where GitHub Actions is used for triggering, while Tekton Pipelines is used for execution. So in this use case, a developer pushes code to their repo, which then triggers a GitHub workflow or action that triggers a pipeline run. The pipeline run itself has a couple of tasks, including cloning, linting, testing, building, and run. The first four come from the catalog, while the last one is from within the repo itself under the Tekton folder. These tasks share a workspace between all of them, which is a persistent volume claim. So let's look at this in action. So if you go to the GitHub Marketplace and search for Tekton, you'll find TKN, GitHub Action. TKN is the Tekton command line interface. So your prerequisites, usage, and version, and a demo at the end. When you click on Use Latest Version, you'll see a snippet as well as a link to learn more. In the repo itself, you'll see the same documentation. And in here, we have workflows to demonstrate usage. And you can see that we are validating that has installed the expected version of TKN. So let's manually trigger this and see what happens. So we quickly run and you can see that it has installed version 18, which is the latest version of TKN. You can also curate it and give it like version 16 as well, and it will install the expected version as you set it. Let's look at the demo, which shows how all this comes together. And here we'll use Hello World Go application. In hello.go, you'll see Hello World as expected. In the test file, you'll see one simple test case. In the Tekton folder, you'll see a bunch of resources. And then when you go to the workflows in the CD YAML, you'll see the installation of the catalog resources that we expect, as well as the execution of the pipeline. If you go to the catalog, you'll see all these many tasks. And we'll just look at an example where you have Golang build, and that's available with the documentation within the catalog. Okay. So in this workflow, you can see the triggering of the pipeline run with particular parameters and workspace. The pipeline itself has all the tasks that we expect, from cloning, linting, testing, building, and running sequentially. And they have a workspace, which is a persistent volume clean. The last task, which is not available in the catalog, is provided locally here under the Tekton folder. There. Exactly. So let's go to the Hello Go file and modify that to say Hello Silicon instead of Hello World. Okay. Then we're going to validate that this is the only change that we're making. Then we'll add, then commit, and push this change. And this immediately triggers a GitHub action, and you can see here that it's running a pipeline. So when you go to the code and check the commit number, you can see that it starts with 650, and the pipeline is running, it's installing Kind, Kubernetes in Docker. You could also connect to GKE or whichever other Kubernetes infrastructure you have. It's installing Tekton Pipelines, installing TKN, then installing the catalog resources you're expecting together with the Golang run, which is a local task. You can see there the description, the parameters, the workspace that all of these tasks expect are logged. And at the top, you can see TKN was installed version 18 for Linux. And you can see the logs for setting up Tekton Pipelines itself with namespaces and all other resources needed. Then you go to the pipeline run logs, you'll see clone run as expected. You can see the SHA with 650, which is the SHA of the change that we just made. Then lint ran successfully, and you can see testing passed with the coverage detail included there as well. You can see building ran successfully, and run should be printing Hello Silicon, which we have there at the end. When you list the pipeline runs, you can see the pipeline run and its status. Similarly, when you describe it, we can see all the task runs that ran under that pipeline run. And we can see the work area, the volume clean. We can see the results, which is the SHA of the chain that we just made. And there we can see the status of the CDS passing. So with that, what's coming next in Tekton? First, we have composability and usability proposals in flight right now. For example, pipeline in a pod. pipelines in pipelines, remote resource resolution. Secondly, we have failure and skipping strategies in flight as well. This includes ignore step errors, task run breakpoint on failure of a step, ignore task failures, graceful pipeline run termination, and skipping strategies. In summary, here in our talk, we looked at interoperability and continuous delivery. And it's possible for all of us to live in an ecosystem. It's not about one project solves all the problems or all use cases. And we highly recommend to try and utilize the entire ecosystem that fits best for your use cases. One size fits all is not scalable. So the idea here is to spread awareness that it's not Tekton or another CICD tool question forever. Ideally, you'll be able to use Tekton and other CICD tools. Thank you.
Thank you, everyone. And let us know if you have any questions.
Hello.
Thank you, everyone. Hello.
Thank you. We put some questions in the poll if you're trying to take a look and answer them. And it seems we have one question here from Sergio. It's not clear to me what parts of the demo done by Tekton versus Argo, from what I understand. Argo was used for deployment only. Priti, can you answer that?
Yeah, sure. So Argo is used, so we created two applications, two Argo applications, one for Tekton resources and the other for the deployment. And Tekton Tekton pipeline was used to build and basically create an image. And that image was pushed to the container registry. Like I said, it's very simple use case, which can be extended to include whatever requirements you have. So, but the idea is here basically using Argo CD to deploy the Tekton resources, which in turn deploys the application.
Thank you. Wondering if you can share, Priti, what other exciting things are happening in Tekton that you're excited about since we made that recording?
Right. So this recording was done quite a while back, and since then we have been working on some exciting features. We have um, the custom task was recently introduced, maybe a few months back, and we have the SDK being designed for custom tasks. So basically, help kind of instead of writing the whole controller by yourself, we are trying to come up with SDK which can help in, so we don't have to worry about all the logic and all. The next we have is Tekton Workflow, which was very recently discussed in the working group, where the idea is basically, so we have a Tekton pipeline and trigger. They're two separate projects. So we are trying to bring them together and kind of like we have Argo Workflow. The recent couple of implementation features we had is the graceful pipeline run termination, which is basically um, when we have the finally task, we are kind of and again the timeout. So both the features were related to the finally task we have, and making sure guaranteed that those tasks are getting executed. So those are the couple of updates or kind of interesting features that we have been working on.
Yeah, exactly. Yeah, I think some of the things that you've mentioned, like the custom tasks, SDK, actually all of them are in the tips that I've linked there. But for the custom tasks and experimental features, there's also an experimental repo if you'd like to try them out yourself. There's a question from Sergio. How do you see Tekton being used in large organizations? Every developer team has a Tekton cluster that they use, or do they have a centralized Tekton cluster? I don't know what you think, Priti, but I think very much depends on the requirements of the team or the organization. If there's reasons for isolation that you may not want to share a cluster, so I think my answer would be it depends, but I wonder what you have to say, Priti, on that.
So yeah, no. So the way we dog food our own thing. So we basically we have dog food in Tekton. And we have the cluster. So whenever there is somebody creating a pull request, we run our own pipelines. We have created pipelines, which is running integration test, unit test, linting, go coverage, a lot of these things. And there's one single cluster, which is being utilized for that, for the one project. So it depends, like Jerop is saying, it depends how you want to kind of isolate it or um, make it so that it basically the entire team can utilize it.
It's okay. A follow-up, can Tekton support a centralized Tekton shared by many teams? How do you separate executions among the teams? Um,
So I, yeah, go ahead.
no, I wanted to say like one way of execution can be or separation can be along namespaces, but I wonder what else you wanted to say.
Yeah, I was going to say the same. So we have seen quite a few users using namespace as the segregation factor, and it's been basically working for them. So
Yeah, exactly. Um, Trying to see. We have a couple of responses on the polls. Everyone has heard about Tekton. Cool. Yeah. Thank you for participating in the poll session.
yeah, thank you for joining, all of you.
That's it. Actually, one more link we can share is the community repo in case anyone has like wants to contribute or has any questions about that or how to reach out to us.
Yeah,
Yeah.
sure, Sergey. Go
Now
ahead.
Sergio has another question.
Go ahead. Uh, it so basically a namespace, you are kind of crossing the namespace, right? I don't know. I have not tried actually. So, but it depends on how it's configured. If you have we have this privileges, right? So if you have set it to kind of access the entire namespace or whatever across the namespace, then yes. But basically, if you have limited the access, then of course you cannot. So I have not tried it though. This is interesting. Uh,
Yeah,
so
and I wanted to point out that this is like an ongoing discussion around separation of concerns between teams, like platform teams versus developer teams. And actually, there's like an ongoing thread happening right now in the Tekton Slack regarding separation of concerns across teams and how we want to represent them within Tekton. Well, like possibly like one team is only authorized to write and one team defines the policies for executing the pipelines or whatever the case. So if you're interested, you can, or if you have thoughts or comments or requirements around like teams and how they interact with pipelines and tasks in Tekton, this is an ongoing discussion happening, and feel free to join in the Slack channel. Which one is it? Pipelines. Yeah.
yeah, feel free to let us know if you try and run into any. Uh, and if you're, yeah, we are very active and vibrant community, and we'll welcome anyone joining us.
Yeah. Okay. Thank you. Thank you, Priti.
Yep, thank you, Jared.